chain rule. Just like what it said, chain is going to be linked. So find the derivative. Today's objectives. Find the derivative of composite function using the chain rule. So that's important word here. It's a composite function. So chain rule is using it where? Composite functions. That's right. We haven't done composite function. Remember G of f of x, right? So find the derivative of function using the general power rule. Simplify the derivative of a function using algebra. Find the derivative of trigonometric function using the chain rule. That's what we're going to cover today. And we have yet to discuss one of the most powerful differential rules, the chain rule. The chain rule is very, very powerful. You will love it. This rule deals with the composite functions and adds a surprising versatility to the rules discussed in the two previous sections, which means what power rules and constant rules, product rules, quotient rules, all the things that you learn, we're going to use with the chain rule. So for example, compare the functions shown below. Those on the left can be differentiated without the chain rule, and those on the right are best differentiated with the chain rule. So if you have problems like this, you can just use what? Power rule and constant rule. Well, if you have this one, you don't know how to take a derivative. Okay, if you write this down as a power rule, you get what? X squared plus 1 to the 1 power. 1/2 power, you don't know how to do this. All right, we don't know how to do this. That's why we need to learn chain rule. The chain rule will give you how to take a derivative of this kind of functions. Same thing here, we know how to do sine x. Sine x is what? Derivative will be cosine x. I know how to do. But better, if it is 6x, you're going to say, oh, what is that? Is it cosine 6x? Or is it cosine 6x times 6? There's something to it, okay? You got to use a chain rule for it. Basically, the chain rule states that if y changes dy du times as fast as u, and u changes du dx times as fast as x, then y changes dy du times du dx times as fast as x. So I will show you what that means. So this is a perfect example. You can see that as a picture. You can kind of figure out what chain rule means in an application way. So a set of gears is constructed as shown in figure 2.24, such that the second and third gears are on the same axis. Is everybody with me? The second, the gear 3, and then what, gear 2 in the same axis, axis 2. Are you with me, class? Okay. As first axis revolves, it drives the second axis, which in turn drives the what? Third axis. So you have a first axis, you gotta move to turn which one? Second axis. And second axis to help to turn which one? The third axis. Are you with me? You see the picture? All right. So let YUX represent the numbers of revolutions per minute of the first and second and third. So we're gonna put this to what? We're gonna put this to be Y, this to be what? U, and this to be what? X. Got 3 variables now. Okay. Now, find the dy du. This means what? Changing y to what? Changing u. What's this mean? Changing u over changing x. That's right. And changing y over what? Changing x. Okay. And show that, we're gonna show this. The changing y over changing x is same as what? Changing y over changing u times what? Changing u over what? Changing x. So I have 2 rate. You can also think about this and this will cancel out. You get only what?
Yeah.
dy dx. Are you with me, class? You can think that way. Now, so, okay, let's look at this picture first. I'm going to look at the picture. Okay, right here, this is what? The radius is 1. And this is how many?
Three.
3. So how many times does gear 1 has to move to make this one turn? 3. Then you have to move 3 times what? Make this one, the big one what?
Turn.
Turn 1 time.
Okay.
So are you with me, class?
Yes.
So in other words, dy du is what? 3. You gotta turn 3 times to move one of this. Are you with me, class?
Right.
Now look at this one. This gear and this gear. This is a 1, radius is 1, this is radius is what? 2. So how many of this needs to turn this gear?
1, 2.
Twice.
Yeah.
Am I right?
Yeah.
Because this one has to move twice to make this one what? Turn 1 time. Are you with me, class?
Okay.
Okay. So, similarly, the second axis must make 2 revolutions. So, dy du is what? 3. du dx is what? 2. Does everybody see how this number got from? So, that means, if I combine them all together, all right, the rate of change, first axis with respect to second axis. Next one is what? Rate of change, the second axis with what? Respect to third axis, what do you get? This, right? What's the number? 3 and 2. So what do you end up with? 6. In other words, the first one do the what? 6 times, then move what? Entire things what? 1 time. That's what that means. So that's a chain rule. Okay, it's a composite. You have to do one thing to make the middle one move. And the middle one has to do what? More work to make what? Last one move. That's a composite function. That's what chain rule is. So, the rate of change of first axis with respect to third axis, that's what that means. Which means it's 6. 3 times 2 give you 6. Alright, so this is what that means. So chain rule, so if y is f of u, does everybody see that? I didn't use x, I used what? U, okay? If y is f of u, it's a differentiable function of u, and u is g of x. Are you with me, class? So I have 2 functions, composite functions. It's a differentiable function of x. Then y is the same as what? F of what? G of x. I'm replacing u as what? G of x. Because that's what it says over here. All right? So dy dx is the same as dy du times what? U over dx.
You still get dy.
So I can also write it as what? dy dx of what? Composite function. That's what that means. All right, let's look at the example. Well, we got the concept. Let's look at the example. So I have this problem. So y is this. So y is that y equal to 1 over x plus 1. So I'm going to rewrite this function as u and x. Are you with me, class? So I'm going to make this to be what? U. Are you with me, class? Make this to be what?
U.
U. So x plus 1 is u. So what's my y then? Y equal to what? 1 over u. Do I know how to take derivative over that? Yes. Yes, how do you take? So this one I will rewrite it as what? U to the what? Negative 1. Do I know how to take derivative of that? Yes,
Yes.
what's that? Negative 1, u, and then what? Negative 1 minus 1. And I got to take what? Take a derivative of u, which is du. Which give you, okay, I will tell you what to do about du in a minute. But anyway, you know how to take a derivative. All right, so next one. Don't worry about taking derivative right now because I just want you to recognize what u is, okay? So now you have this. Y equal to sine 2x. What's my u? 2x is my u. I want you to know how to substitute it. So you know how to take a derivative of u. All right? So you got this. So your y is equal to what? Sine u. Next one. I have this. What's your u? You're going to use u as what? Inside of what? Radical. So this is your u. U is equal to this. So we write the problem as what? Y equal to square root of u. I just want you to recognize right now. Only thing you have to do is like you need to recognize what am I going to put as a u? What I'm going to replace as a u? So did you see like denominator become a your u and then what? The elements, argument is your u, and then what? Radical, under the radical is your u. Are you with me, class? Let's see another example. You have this, what's your u? tangent. So I can write it down as what? U squared.
So you plugging that into that, basically.
Right, so
Alright.
right now I want you to figure out how to make this problem as what? dy dx is same as what? du times
Yes.
what? Dy times du, and then what? Du times what? Dx. Are you with me, class? That's what I'm trying to do. So you need to figure out how to replace this as what? U, because that would make it easier when you take a derivative. Okay, general rule. So this is the chain rule. This is how you take a derivative. What do I do? Like a power rule. Are you with me, class? It's like a power rule, but what do you do? Take a derivative of u. So n, so you have this. That's a power rule, right? You have something to the power. But remember, you have a u of x. There's a composite function inside right here, okay? So you do what? Put the n in the front, u of what? X, and one less power, and then what did you do? This is your new thing. What do you do? Take a derivative of what? That function, du dx. Let's look at the example. When you look at the example, it's much easier. I have this. Are you with me, class? What's my u? Can somebody tell me what's my u? What would you use? 3x minus 2x squared. Does everybody agree? So I'm going to put the u as 3x. All right, this shows everything. U equals what? 3x minus 2x squared. Everybody agree, right? Good. So I'm going to rewrite this problem as e to the third. Do I know how to take a derivative of that? So this is what I do. Bring down what? 3 in the front. 3x minus 2x to the what? 1 less power. Am I right, class? 3 minus 1 give you 2, and then what do you do? Take a derivative of what? This, inside of that. That's what you put it in here. So what happened from, what's the difference from power rule? The power rule, you finish it where? You done it right there. Are you with me, class? Now this is a chain. What's your chain? You're linking. That part. Taking a derivative of what? The inside of the parentheses. That's why it's called chain rule. You're linking. This is a new part. Is everybody with me here?
Yeah.
All right. So what do you get then? So we got this. Derivative of 3x is what? 3. Derivative of this is what? 2 times 2 is negative 4, and then 1 less power become our x to the 1. Is everybody with me?
Yeah.
You're done. If you don't want to, you don't have to go anymore. This is fine. All right, your answer, if you give it to me this on your exam, you get a perfect score. You don't have to expand this, unless I ask you to expand it, okay? This is fine. Is everybody with me? So only difference from regular power rule is what? I got the linking part. What's the linking part? Take a derivative of what? The u. Are you with me, class? The inside of this, u part. That's your u part, remember? This is take a derivative of this u part. Is it following me, everybody?
I got you.
All right, let's do another example. This. Okay, so we're gonna do same. This is a little more complicated because this is what? So I get to practice product rule and chain rule at the same time. So like in your exam, when I give you chain rule, they can practice everything at the same time. So I'll definitely give you one problem from chain rule because they will use power rules and other things that you have to learn. You have to know. So find the derivative of this. We have this. And then what do we do? I want to change that into what? Power. Is everybody with me? I just rewrite it. I haven't done anything. I just rewrote it. All right, now what do I need to do? First, do you remember your product rule? If you have two functions, do you remember your product rule? So if I want to take derivative of this, what happens? F times g prime and then plus what? G times f prime. Remember that? That's what I'm doing here. So,
You did yesterday.
this is my F, and this is my what? G. Is everybody with me?
Yeah.
Okay. So, F times derivative of this. Is everybody with me? The next one is what? This times what? Derivative of the second one, the first one. So far, so good? Okay, this is part that we gotta use chain rule.
Chain rule.
Everybody with me? Why the chain rule? Because I have something to the what power, and I need to take a derivative of inside of here. Are you with me, class?
Yeah.
All right, so move on to next part. So I got this. Now this one, class, look at this. Take a derivative of this. How would you take a derivative? Let me go back. All right, we got this much, right?
Right.
Next to that. You understand up to this much? Is everybody with me? Okay, now here. So let's take a derivative of this. So I have x squared times, how would you take derivative of this? Using a power rule, right? So what do you do? Put 1/2 in the front, am I right?
Right.
What else? 1 minus x squared, 1/2 minus 1. And then what I need to do, I'm not done yet, right? I gotta do my derivative of this. What's my derivative of that? 1 is 0. This is what?
2x.
Negative 2x.
Ah.
Is everybody with me?
Yeah.
The green part is my what? Du dx. Is everybody with me? I just use a chain rule. And the other one, I don't have, that's nothing much different. The other one is just like we've been doing. And the derivative of this is what? 2x. That's it.
It. For
Right,
that
but we're
part.
not done yet.
Yeah,
We got
for
to
that
simplify
part.
it, right? We got to simplify it. Class, so what are you seeing right now? Only difference from this and this is what? This use chain rule. That's why I have an extra color right here. Does everybody see that? I took a derivative of what? The inside of this parenthesis. This is my du dx. I use a chain rule. And I use different colors so you can see it. This is a regular function, this is derivative. And this is the derivative of a du dx. Are you with me, class? Now, looking at this, say when I say, okay, can I simplify some?
Hey, you canceling 2x? Is that cancel?
Yeah, I think definitely cancel that. So this and that cancel out,
I'm about to run it. Oh.
okay? And then let's just simplify this part. So what do you have here? You have an x squared, an x that give you what? Negative x to the third.
Yeah.
Are you with me, class?
Say
Multiply
that again,
this.
say that again, say that again.
1/2 and 2 cancel out, am I right?
How?
1/2 times 2 is what?
You multiply.
This is same as what? 2 over 2 give you what?
One.
1. So this and this just become a what? Simply 1. Is everybody with me?
Okay.
Okay, are you following me, class? Okay.
Yeah.
Next one. X squared times x give you what? X to the third.
Yep, I got
Everybody
you.
good?
Yes.
I have a negative sign because of this. Are we with me?
Mhm.
All right, next one. What's this one equal to? 1 minus x to the square to the 1 power now. Negative 1/2. So far, so good? All right, now let's combine the other one. What do I have? The other one just have a what? I cannot combine anymore. This is good. Just like that is fine. So I'm gonna rewrite it then. All right, is everybody with me? So far, so good? Okay, let's see what's my common factor I can factor out. Okay, this is a little bit common. Okay, once you do it, you know what to do. But this first time is just a little bit hard, okay? So let me not look at negative power, how about that? If I do negative power, then what happens? That'll be easier for you then. So which become easier? If I bring out the negative 1/2 power, are you in class? Negative 1/2 power instead of positive 1/2 power, so it's easier for you. If I bring a negative 1/2 power, this just become a what? Plus 1, so I will just have 1 in the front. Am I right, class? But what about this one then? I'm bringing out the negative in the front 1/2 power. You can think of yourself, okay, I'm gonna make this to be so. How am I gonna explain this one?
It's tricky.
So I'm gonna bring out I want to have negative 1/2, so I can bring it out. Are you with me, class? Right? So which means I need to also do the same thing to what? Negative 1/2. Are you with me, class? Remember, this becomes the same as 1. Same thing divided by same number, same as what? 1. You can think of this. If I divide by 2/2, what do you get? 1. So I'm not changing. Are you with me, class? Since I want to factor out 1/2 power, negative 1/2 power, I'm gonna do like this. Negative 1/2 power divided by negative 1/2 power. Are you with me, class? Are you following me now? You can just think that way. That will make it easier for you. So what do you have? So this means I'm bringing this one out, right? In the front. So what are you left with?
So -1.
So I have x to the what? 1/2 divided by what? X to the what? Negative 1/2 from here. Am I right, class? Are you following me, class? It's not hard. Just think as like you multiplying 2/2. So you think what? X to the 1/2 divided by what? X to the 1/2.
So what that
Because I want to bring this one out in the front, I need to find the common factor. Like here, this and this is a common factor, but their power is a fraction power, so it's a little more confusing. So I'm trying to explain to you how to think about it. So you almost done. X to the 1/2 divided by x to the negative 1/2. What you really mean? Look at this part. What's that really mean? X to the 1/2, and then what? Minus 1/2. Am I right? Same base. Division. What do? You subtract. So what's that equal to that? So what do you get? X to the 1 power. Are you with me? Not yet? Not yet? Okay. Not yet. That's fine. Not yet is fine. Here. Before I finish this one, I need to review with you guys about the 1/2 power. Everybody watch me. You're almost there.
Yeah, I'm trying to.
Let's look at this one again.
Huh?
Are
I
you
thought
in
that
class?
was negative 1 for sure.
Oh, excuse me, not the negative one. That'll be the easy one, right?
I know, I got it, I got to get it.
All right, class. Let me try a different power, not the 1/2. How about that?
Yeah.
So make sure that you understand the concept. So if I have this, x to the negative 1/3 plus x to the 1/3.
Okay.
Are you with me? I want to factor out negative 1/3. Are you with me, class?
Right.
I chose to factor out negative 1/3. Are you with me? All right, so I'm going to say, okay, let me rewrite this problem as 1 times x to the negative 1/3. And the other one, I'm going to say, okay, I have x to the 1/3, but I need negative 1/3. So I'm going to provide what? X to the 1/3. If I do that, I'm messing up my problem. I cannot just multiply something. So I need to also do what? Divided by what? X to the what number? Negative 1/3. In this case, did everybody agree? X to the negative 1/3 divided by x to the negative 1/3 is equal to 1.
Yes,
Am I right?
right.
Just like x over x is equal to what? 1. What? 2 over 2 is equal to what? 1. Two exactly same number or same expression is equal to what? 1. So when I multiply by 1, am I changing anything? No,
it's the same
because
thing.
1 times anything is what? Anything. Because 1 is identity of multiplication. So what I just did is simply actually I multiply by 1. Same as what? 1. Are you with me, class? I'm just doing the trick. The trick is what? The 1 that I want to factor out, I multiply by it, and then what do you do? Divide by it.
Okay.
Does everybody understand? Do the trick. I'm giving you the trick. Whenever you have something like this negative power, you gotta factor out by the negative power. Then I'm almost done.
Okay.
Everybody agree? My common factor is what? Oops.
Yeah.
Everybody agree? That's my common factor. I'm bringing that out. Then I left with what?
1.
1 plus what else?
X.
X to the
1/3.
1/3. Everything divided by what?
Negative.
With negative. So divided by what? This.
Alright. You right here now.
We're done pretty much.
Alright.
Now what do I need to do? Simplify this. What's that equal to? What's that equal to? I'm almost done. What's that equal to?
1.
According to the power, remember that we learned the expression? X to the 1/2 divided by x to the negative 1/2 really means what? X to the 1/2 minus negative 1/3. Am I right? Because the same base
Oh, so, okay.
Because
Oh.
division, what do? You subtract.
I feel you. It ain't like
That's why I
that.
gave you algebraic homework problem. Remember the worksheets? You have done this kind of worksheets, okay?
So,
So what do you have?
X.
X to the 1/3 plus what? 1/3 give you what? X to the 2/3.
There you go.
So I
got
can
you.
rewrite this problem as x to the negative 1/3 over what? 1 plus x to the what? 2/3.
Alright, now we rock it. We roll it. Let's
Are
go.
you following me? What's the trick that I did?
There.
I chose to factor out whatever the negative negative power is, okay? The negative power is the one you have to factor out because you have to do the least common factor to bring it out. Not the greatest common factor, but the least common factor, which means you gotta choose a smaller power. You bring that out. Since you chose to bring that out, that means I have to multiply by what? Whatever the things I factored out. So I multiply that, that means I have to divide it. Because this really means just multiply by 1. This times 1 does not change equation. Then you do that, and the last thing you have to do is what? You combine these two power, 1/2 minus this, which gives you positive 2/3, and you're done.
Alright.
Are you
Alright.
following me? So let's do our problem.
I got it. Now let's go back to the other.
So we have this. So we're gonna do the same thing again.
Go back to the other.
I'm gonna factor out by what? Negative.
Negative.
So. Is everybody with me?
Okay.
What else I can factor out, by the way? This is x squared, and this is x. Can I factor out x also?
Yeah.
You don't factor out negative?
Negative x squared.
No. I have 3 of this, right?
Right.
I have a x times x
Yeah.
times x. And I have a 1x
Yeah, right
over
there,
here. So can I factor this one out, one of them out?
Yeah. Yeah, I got
All
that.
right. So what are you left with? This case is what? Negative x squared.
There we go.
This one I don't have anything left, right?
Right.
So I have, this is the first one. What about the second one you have?
You got a little something left.
Second part you have a what?
2.
2. What else you know about this one? When you factor this one out, what do you get?
Hey,
We already have done it.
Yep.
So end up to be what? 1 power. 1 power.
1 power.
Are you with me, class? When you factor out negative 1/2 as your common factor, what are you left with? This become a what? 1 power. Remember, I just did it up here. I proved to you that become a what? 1 power. So this one end up to be what? 1 minus x squared to the what? 1 power.
Is that it?
I'm almost done.
Oh, man.
Okay, this is done part, but I need to finish this part. This is what I need to factor that out. What's that equal to? So negative x squared plus 2, this give you what? Negative 2x squared. So combine this, what do you get? Negative 3x squared plus 2.
Right.
So I'm almost done.
At the she factoring at the bottom right there in the blue.
I just multiply them out.
Distribute.
Yeah, distribute it.
Yes, sir.
So this and that, they give you that. So I'm done. I need to, okay, did you write this down about why become a one? Because I want you to understand why become a one. Because I'm gonna use calculate.
I ain't want to.
That's what I'm trying to tell you. This part that you got, like kind of like a slowed, okay, like a break, is not the concept of a chain rule.
It's a
What's
part.
the part of doing your algebra? Are you with me? That's why I keep telling you, you got to practice your algebra, because the concept of calculus is not that hard. But to get to that point, to get the end point, you gotta know a lot of algebra. You gotta do your algebra. Good. All right, so we're almost done. Now we write the finish up on the same page. So I'm gonna move this everything over here. So I have x and then 1 minus x to the what? Negative 1/2, and then what do you have here? Negative 3x plus 2. All right.
Square. A squared right there.
Oh, excuse me,
There you
square. All right, so since it's a negative power, I need to put this into a denominator. So x, negative x squared plus 2, everything over what? This. Since it's a half power, I can write it as what? Radical square root, that's right. So we're done. So practice, okay? It's not hard, you gotta practice, yes.
On the PowerPoint, there's supposed to be an x squared and not.
Oh, yeah, there is.
X squared, did I not start my problem right?
Something, we messed up somewhere.
Let me see. We got this one, so, where did I not do my problem? Okay, you got an x
Right here,
squared.
right at the bottom where it says x,
No.
right there.
This one?
In the parentheses, that x is supposed to be squared.
Oh, this one? Oh, okay, I just didn't write that right, okay. Thank you.
Cool.
Right here. Okay, I dropped my x squared. The problem says x squared right here. But I'll keep writing down as what, x, yeah. So is everybody with me now? It's not hard, class, since you understand how you get this become a, or the hard part is what? Become a what? 1 power. All right, so when you factor out the negative 1/2 as your common factor, the other 1/2 power become a what? Half plus half give you 1 power. Are you with me, class? If you don't want to do all this algebra, then just memorize yourself. Okay, if you factor out the negative 1/2 power, the half power become a what? 1 power. And I showed you why. Okay. All right. So this is a hard one I just did. By the way, your homework problem is easier than this. Whenever all your homework problem, make sure this is easier than this. So everybody got that, just like we did? Simplify, so you have this. They didn't show all the steps we did because they assume that you understand why this is 1 power. Because you common factor which one? Half power.
Those half.
Are you with me? Negative half power, that's why. So I didn't skip any steps so you can see why it's true. All right, we have this one. Now we're gonna do what? That one was a product rule. Now we're gonna do what? Quotient rule using a chain rule.
This is good.
All right, first thing first, make that into what?
That.
Third power. Everybody with me, this is my F, this is my G. Right? What does your quotient rule says? It says what? G squared, and then what? G times F prime minus what? F times G prime. That's your quotient rule. So derivative of that, all right, how about I write this down?
That makes sense.
First thing first, my F is what? X. What's my F prime? 1. Everybody with me? That's my G. G is equal to what?
A squared plus
X squared plus 4 to the what? 1/3. What's my G prime? G prime is the one you using a chain rule. Are you with me, class? It says I'm gonna use a power rule, but it's like a super power rule. Are you with me?
Right.
So I do what? 1/3 x squared plus 4 and 1/3 minus 1. Am I done? No. And then I gotta take a derivative of what? U, right? What's that equal to? 2x.
2x.
Only 2x because this become a 0. Is everybody with me?
Yep.
So when you do quotient rules or product rules using a chain rule, write it down. What's your F and what's your F prime? Write down what's your G and your G prime and plug it into your formula after that. That's the best way, yes.
How do you know when to put the U in?
Or whenever you see it like a radical, whenever you see a radical, and inside the radical has more than one expression, one term, you got to use a chain rule. Okay?
Formula for the chain rule, so I can know like where to put it in.
The chain rule is like this. Chain rule is like a power rule. So you have this as a y. Chain rule says what? N times what? G of u, n minus 1, and then what do you do? Take a derivative of u. U prime. That's the chain rule formula. That's what I just did here. Like a power rule, but what's the one more you do? Take a derivative of this inside. That's the only difference. So if you know how to do power rule, chain rule is what? Power rule plus what? Regular what? Derivative. You're doing it one more time. You take a derivative of inside of this. All right, so I'm almost done. So what do you have this? Can I rewrite this problem? I need to simplify this power. What's that equal to then? Negative 2/3? Okay. So I have 2 and this. We have a 2x over 3, and then what? X squared plus 4 to the negative 2/3. So that's my G prime.
Dr. Cruz,
Yes.
you got the, how did you get the 2/3? I mean,
Yeah.
the 2x over 3.
The 2x is over here, so I brought this into a, in the front of that.
Yeah.
You have a 1/3 times 2x.
It's like the same as 2 over 1.
So 2x over 1. So 1 times 2x give you 2x. 3 times 1 give you another 3. Are you following me, class? Okay. Okay. So we got so far so good. So I'm gonna just, as I said before class, if you have a product rules or quotient rules that include what? Chain rule, what do you do? Write down your F and F prime. Write down G and G prime, and then what do you do? Plug it into your quotient rule. So quotient rule says what? G times F prime. This is your G, does everybody agree? F prime? Yes.
So do we have to do it like
Yeah, that's kind of long.
the way over here? Like put it, I don't even know how it happened with the 2x.
Supposed to be easier. I thought.
Right here? Yeah, this 2x came from this. Yes, you did it.
No, I'm saying like,
Okay, watch. Let me explain, okay? So everybody agree this is F and G prime. Are you with me, class? Minus, I'm doing a formula. Minus, and what do you do? F, where's my F? X. What's my G prime? 1/3 times what? X squared plus 4 to what? Negative 2/3 and times what? 2x. They just selected this one as well, okay? Everybody with me?
Yeah.
So far so good? Divided by what? G
Squared.
squared. So this got 1/3.
You squared it.
You square them. Everybody with me? So if you have this one to this, all right, this really means what? X to the 1/3 plus what? Times x to the what? 1/3. So how many you have? 2/3. 1 plus 1 give you 1, 2. That's what that means. You got 2/3. So far, so good? Since I have negative power, you know I'm going to factor out which one? I'm going to factor out which one? Negative power. Okay.
You write that down, the red over there, where you did the x to the 1/3, is that.
Oh, you want to show how I did it? So you have x to the what? 1/3 to the second power. That really means what? X to the 1/3 times, how many do you have? 2 of them. So you have 2. So what's that equal to? X to the what? 2/3. Because 1/3 plus 1/3 give you what? 2/3.
Wow.
Okay, everybody with me? All right. So this is the same as this one, right? I've replaced this with the what? This, then you get the same thing, okay? All right, now class. Think about it. If I factor this one out, 2/3. Let me do the next page again, because I want you to understand. Just thinking as this, I have, what was the other one has? What power does it have? 1/3 power, and I'm factoring out 1 2/3. Is that right with me?
This is easy.
Alright, so same thing, I'm doing it one more time. X to the 1/3, and the other one is what? X to the negative 2/3. I want to factor out what? 2/3, negative 2/3. Are you with me, class? I chose to factor out this.
That's what she chooses.
So I need to multiply this by what?
1.
2/3 and divided by what? 2/3. Is everybody with me?
Yeah.
Because I chose to factor out negative 2/3. So I have to do this. And now I can say what? I will factor this one out. I can bring that out in the front. So now what do you have? X to the what? Negative 2/3 as my common factor. What are you left with? X to the 1/3 divided by what? X to the negative 2/3 and plus 1. Is everybody with me again?
Yes.
And you're gonna tell yourself this is the same as what? 1 power? Is everybody with me? This is the same as what? X to the 1/3 minus 2/3, which give you the same as what? X to the 1 power. 1 power again.
Okay, I see. That's it.
So you're gonna tell yourself, okay, I got the shortcut. Whenever I factor out the negative power, it looks like to me to end up with what? 1 power.
Okay.
Something that you can work with easily.
So I don't know like this.
So always, the important thing is what? What you decide to factor out, you're gonna multiply and then divide it. Are you with me, class?
Gotcha.
That's the trick. Multiply and divide, exactly same negative power. We're almost done. So I will finish up, because I'm not gonna come back to 2.4 tomorrow, I'm gonna do 2.5 tomorrow. Are you with me, class? So, do your homework. By the way, your homework is not this hard, I promise you. I chose a homework that just practice your what? Chain rule. I know you're almost done. Give me 2 more minutes.
Yes, ma'am.
So does everybody see that?
That's what they did.
This is what we did. Factor out negative 2/3. Now this become a what? 1 power. This is what? You multiply more this to give you this. Okay? If you simplify that, you get this. I promise you, I'm not going to do this hard problem, but I want you to understand how you're factoring out the negative power. All right? So that's it.